Okay, everybody, this is chapter 4, section 4.1. And what we do in chapter 4, we're still doing the solving the inequalities. It's called linear programming. And in chapter 3, we did it by graphing, and that's considered a geometric approach. And in chapter 4, we're going to use matrices, and this is considered an algebraic approach. So let's talk about standard maximization form. So we want to get the objective function. We need to get that maximized. There's also problems where we're going to minimize. So I like to say you have max function or max problems, like max for maximization, min for minimization, so max and min problems. We're just going to look at the maxes right now. Then each variable is constrained to be greater than or equal to 0. So if you just skip down right here, this problem here, notice those are all greater than, or I'm sorry, those are less than or equal to. I was looking at the wrong one. X is greater than or equal to 0, and Y greater than or equal to 0. And then in number 3, we're really talking about my inequalities here. Those are all less than or equal to some non-negative number. So 96, 18, 72, those are non-negative. So don't worry too much about this. That's just putting in formal terms. Okay, so we want to talk about slack variables. Let's talk about this one right here. And I'm going back, this is the furniture problem we had in chapter 3. Well, let's just say we got 6x plus 3y. And we know that's less than or equal to 96. So let me just write that over here. Less than or equal to 96. Okay, well, what if I wanted to make it equal? This sign says it could be less than. So what if it's just a little bit less than, and I wanted to make it equal? Then what I'm going to do is add something else in here, and I'm going to put the letter U, and that's going to be a slack variable. And by putting that in there, that makes it equal. So before I did that, since I said it was less than or equal to, maybe I did all of this and it was equal to 93. That means I would have to add 3 more to get up to 96. Okay, so that U is the amount extra you're adding on. In other words, it's picking up the slack. That's where the word slack variable comes from. Okay, fine. Let's go to the second inequality I have right here. X plus y. And that's less than or equal to 18. But I want to make it equal to 18. So, you know, perhaps when I took x plus y, just for example, maybe it actually added up to 17. Well, 17 is okay because that's less than or equal to 18. But if I want to make it equal to, then I've got to add a little bit more. This might be a little confusing, but now I'm going to add in a different variable, v, because these two might have different values, but they're both slack variables. U picked up the slack for that one. V picks up the slack for this one. Okay, then there was a third inequality, 2x plus 6y. Okay, UV will have to add something else down here to make that equal to 72. So again, I'm picking up the slack. U, V, W are all slack variables. Okay, now the x greater than or equal to 0, y greater than or equal to 0, that really doesn't show up in your work. But that has to be true, or otherwise this method doesn't work. Okay, now let's do one more thing here. The book, okay, I got P equals, so that's like your profit function. Okay, the book lets M represent that, so I'm going to put M equals 80x plus 70y, and I'm going to change the form a little bit. So if I take that 80 over here, put it on this side of the equals, that's going to be negative 80x. I'll do the same thing with the y. I'll put it on there, so that becomes negative 70y. I still have the m here, so plus m, and that would be equal to 0. Let me copy that down here because I'm going to keep this page and use it again here in a minute. So you'll notice what I've done here. You've basically got an x column. See how I lined all those x's up? And then here's all my y's. And then later on, you're going to have a U column, a V column, a W column, and an M column. And then you're going to have all these numbers here. I call those the constants. Okay, so in my notes, I said set up the equation using slack variables. That's what I did down here. And I'll come back to this in a minute. Okay, now what we want to do is set up the matrix. Once you got the equations, this will be pretty easy. I'm going to have 6, 3, 1, 1, 2, 6, negative 80, negative 70. So again, I've got an X column and a Y column. Okay, now we're also going to have a U, a V, a W, an M, and a C column. So we look up here, the first inequality, we had a 1U, then I would have 0, 0, and 0. For V, I would start with a 0 and then have a 1, and 0, 0. And then for the W, it would be 0, 0, 1, 0. And for the M, these would all be zeros and a 1 at the bottom. And then over here, this is 96, 18, 72, and 0. Okay, later on they're going to talk about group 1 variables and group 2. Okay, so right now your group 1 variables would be x and y, and your group 2 variables would be u, v, w, and m. That's not a big concept. If you don't get that right away, that's okay. Between me doing some problems here and you reading your book and that type of thing, that'll all be figured out. Okay, so that's all we're doing with that problem right now. That was just kind of an intro. So let's look at the next page of the notes. Okay, so this is example 1. This is the same thing that's in the book. It says, use linear equations in a linear programming problem. Formulate the following linear programming problem in terms of the system of linear equations. And we want to maximize the objective function, 3x plus 5y. Okay, so set up the equations using slack variables. Okay, so this is going to be easy for you now. So you're going to have x plus y. I do it this way a lot of times. Sometimes it's easier, x plus 2y. So I've only got 2 inequalities, so I start with that. Okay, I need a slack variable here, and we know that's going to be u. And then we need a slack variable here. We know that's going to be v. And then over here, I'm going to make that equal to 20 and equal to 25. That's why it's set up here in terms of the system of linear equations. We're making those into equations. They were inequalities. We're making them into equations. Okay, and then let's do this one. That's my profit function. So let's just say m equals 3x plus 4y. And if I put the x's over here, that becomes negative 3x. Put the y's over here, minus 4y plus m equals 0. So that comes down here, negative 3x minus 4y plus m equals 0. I'm going to zoom that out. See if I can pull that up a little bit. There. See if that's a little better, because I know I keep losing parts of the paper. Okay, so now let's set up the matrix. So I got a 1, and a negative 3. Then I'm going to have a 1, 2, and a negative 4. Now, let's flip back over to the other page, because I want to show you something here. Notice notice this part right here. Oh, don't tell me it's out of ink. I think so. What else do I have? There we go, the yellow works. Can you see what I got right here? What is that? Well, you notice you got 1s on the diagonal and 0s everywhere else. Back in chapter 2, we talked about the identity matrix, and that's what you got. So now when we go back over here, this is the easy way to set it all up once you understand what's going on. We know we're going to have an identity matrix. There's 3 rows. So it's going to be a 3 by 3. So 1, 0, 0, 0, 1, 0, 0, 0, 1. And then your other numbers over here, 20, 25, and 0. And something this book does, I kind of understand, but they'll put a line down here. I rarely put that in, but if you want to put that, that's fine. It might help you understand as you're reading along. Okay, so that's all we had to do is set up the matrix. Okay, so we're in pretty good shape. Okay, let's see what's next. Okay, same type of problem. We're doing the same thing. You'll notice that now we got x, y, and z. So, set up the equations using slack variables. So you're going to have x minus y plus 2z plus u, and that will be equal to 10. You're going to have 2x plus y plus 3z plus a different slack variable v equals 12. Now, I've only got 2 of those. That's good. And then if I set that up, m equals x plus y plus z, put those on the other side, that becomes negative x minus y minus z plus m equals 0. And plug that in here. So negative 1, negative 1, negative 1. I got plus m right here. Oh, I'm sorry, I don't know what I'm doing. Negative x, negative y, minus z, plus m equals 0. I'm getting ahead of myself. I was thinking the matrix. So then the matrix would look like this. 1, negative 1, 2, 2, 1, 3, negative 1, negative 1, negative 1. And then I'm going to have the identity. So 1, 0, 0. It's 3 by 3, so that's how far out I go. And then lastly, you got 10, 12, and 0. And if you want to put that line in there, you can. Your group 1 variables would be x, Y, and Z. And my other ones are going to be U, V, there is no W on this one, M, and then that's it. Okay, then they throw this in. I'm not sure why they did, but they did. So let's talk about it. Let's go. Do you remember in chapter 3, and we were graphing these things, and most of our graphs came out and looked like this, where we'd have, let's just say, lines, and then this was shaded in. And then we found the vertices. So I had 4 vertices. Okay. And out of those, if nothing else, when you look at it, you do know this one's going to be 0, 0, correct? You have no idea what those are. Because I didn't even put any numbers, any scales or anything like that. Okay. So if we go back to this problem right here, there's supposed to be a Y there. Okay, and let's say, since we know this is a solution, it'll, okay, what do I want to say here? The question will be, from these equations, we can find one set of solutions for the system. Since we know 0, 0 works, we can let x equal to 0 and y equal to 0. Because we know that's a vertex of our feasible set. Okay, so now, if you go back and plug those in, so I had 6x plus 3y, I'm looking right up here, plus u equals 96. So if I put 0 in here and 0 in here, you're going to have 0 plus u equals 96. U is equal to 96. Okay, if I did the same thing up here, I had x plus y plus v equals 18. So if I put 0 here and 0 there, v is going to be 18. And if I did this one, so I had 2x plus 6y, I'm looking right up here, plus w, and that's equal to 72. So if I put 0 in for x, I'm going to have 0. Put 0 for y, I got 0 plus w. So w is equal to 72. And on the last one, we had negative 80x minus 70y plus m equals 0. So if I put 0 here, I'm going to have 0 minus 0 plus m equals 0, and m is equal to a 0. What you just did, you found one set of solutions by plugging in that 0, 0. So my solutions were x equals 0, y equals 0, u equals 96, v was 18, w was 72, and m equals 0. So what that does, that gives you one set of solutions. And how did we do that? We let x equal to 0 and y equals 0. Why did we do that? Because we knew our picture is going to look something like this. We knew that vertex was one of the possibilities, and we knew the coordinates of that vertex, so we plugged them in. I have no idea about the others, but those would be 3 other possible solutions. Remember, according to that property, is if we're going to have a maximum, it will happen at one of those points. So, you know what we did last chapter. We found each of those, we plugged them in, and we got 4 values. All I'm doing here is finding one of the values. This is not going to be your final answer, but it is one of the possibilities, and that's what you're doing. Okay. Okay, so by inspection, I want to be able to look at, I've got two examples here. I want to be able to come up with the answers. So if x equals 0 and y equals 0, that's what you're doing here. U is going to be 3. If x equals 0, y equals 0, v is going to be 11. If this is 0, m is going to be 0. And that's all you got there. When I come over here, if x equals 0 and y equals 0, now I wouldn't do this one first. That's going to give you 2u plus v equals that. If I go here, if that's equal to 0 and that's equal to 0, then I'm going to have negative 6u equals negative 1. That means u is going to be 1/6. Had to do a little work on that one. Okay. Now that you know u is 1/6, you're going to have 0 plus 0. So you're going to have 2 times 1/6 plus v equals 12. 2 times 1/6 is 1/3 plus v equals 12. Think of that as 36 over 3 minus 1. V is going to be 35 over 3. Oops, sorry about that. So you got 2 times 1/6 plus v equals 12. Plug that all in, you get 35 over 3. Okay, and then I got to find m. So if I go back to this one right here, I've got 3y, well that's 0. So that's going to leave me with 8 times, we already know u is 1/6. And that's going to be equal to, wait a second, I got missing something here. Oh, plus m equals 4. So that's 4/3 plus m equals 4. So m is equal to, think of that as 12/3. 12 minus 4 is 8/3. So m is 8/3. And this is just one set of answers. That is one set of answers for that problem. And that's all you're doing. It's not going to be the final answer, but it does give you at least one set of answers. Okay. Here's the last thing we're going to look at. A simplex tableau, or tableau, is a matrix corresponding to a linear system in which each of the columns, remember this is kind of what we did in Gaussian eliminations, where we try to get the ones lined up and the zeros everywhere else. It's kind of the same thing. Okay. So let's take this problem down here. I'm just going to jump ahead. Let's say we want to get a 1 where the 6 is. Okay, fine. All we're going to do is take 1/6. Times row 1. So that's going to give you a 1. That'd be 3 over 6 would be 1/2. Then you're going to have 1/6. And 0, 0, 0. And 1/6 of 96 is 16. And the others stay the same. I'm going to go down this way. That'll keep it neater. All I'm doing is copying numbers. And then this becomes your pivot. That's where you got the 1. So let's get zeros everywhere else. So that's 1, 1/2. We've done this before. This is just like Gaussian. And I will tell you, a lot of what we're going to do, it's similar to Gaussian, but it is going to be different. In the next lesson, I'll take you to that level. So negative row 1 plus row 2. So negative 1 and 1 is 0. Negative 1/2 and 1 is 1/2. Negative 1/6 and 0 is negative 1/6. 0 and 1 is 1. 0 and 0 is 0. 0 and 0 is 0. And then negative 16 and 18 is going to be 2. Okay, the next one we're going to take negative 2 times row 1 plus row 3. So negative 2 times 1 is negative 2 plus positive 2 is 0. Negative 2 times 1/2 is negative 1 plus 6 is 5. Negative 2 times 1/6 is negative 1/3 plus 0 is negative 1/3. Negative 2 times 0 is 0 plus 0 is 0. Negative 2 times 0 is 0 plus 1 is 1. Negative 2 times 0 is 0 plus 0 is 0. And negative 2 times 16 is negative 32. Negative 32 and positive 72 is 40. Okay, and then the bottom row, take 80 times row 1 plus row 4. 80 times 1 is 80 plus negative 80 is 0. 80 times 1/2 is 40. 40 plus negative 70 is negative 30. 80 times 1 over 6, that's 80 over 6, or 40 over 3 plus 0 is 40 over 3. 80 times 0 is 0 plus 0 is 0. 80 times 0, 0 plus 0 is 0. 80 times 0 is 0 plus 1 is 1. And 80 times 16, 80 times 16, that's 80, 40, 1280, 1,280. Okay, let me get another sheet. I'm going to copy these numbers. You can see them a little bit better. So we got 1, 1/2, 1/6, 0, 0, 0, 16, 0, 1/2, negative 1/6, 1, 0, 0, 2, 0, 5, negative 1/3, 0, 1, 0, 40, 0, negative 30. I'm sorry, there's no negative, it's just 40 over 3. 0, 0, 1, and that's 1,280. Okay. So now what? Well, remember how we let x and y equal to 0? We've got x where we want it over here. I got 1, 0, 0, 0. So if I change these into equations again, that's going to be 1/2 y plus 1/6 u equals 16. This is going to be 1/2 y. Did I copy it right? I'm looking right here. I'm trying to make sure I did this correctly. So Okay, minus 1/6u plus v equals 2. That's not showing up very good. I keep losing my paper. Try to keep more of it in. There we go. So what I was doing, okay, so this is 0x, that drops out. So I've got 1/2 y, negative 1/6u, plus v equals 2. Now I'm going to go to the next one. This becomes 5y minus 1/3 u plus I'm having trouble keeping track where I'm at. So I got u, 1u plus v equals 2. Okay, so 5y minus 1/3. I don't have any v's, but I've got a w right there. So I'm going to say plus w equals 40. And then lastly, I've got negative 30y plus 40 over 3 times u plus m equals 1,280. I'm checking my numbers here real quick, make sure I got those. So like what we did before, remember how we let x and y equal to 0? Okay, well, x is already satisfied. So now what we're going to do, we're going to let y equal to 0 and u equal to 0. So if I go back to this one right here, I forgot x right here. 1x. So if that's 0 and that's 0, I'm going to have x plus 0 equals 16. That means x would be 16. Okay, that's what this one gave me. Now we're going to work on this one. So if y is equal to 0 and u is equal to 0, I really have v equals 2. Okay, now I'm going to go to this one. 5y minus 1/3 u plus w equals 40. So if that's 0 and that's 0, w is equal to 40. And if this is equal to 0 and that's equal to 0, then m is equal to 1,280. So my solution, I'm going to fit it in right here, would be x equals, what did I say it was, 16. Y equals 0. Remember, we let y equal to 0. U equals 0. V equals 2. W equals 40. And then my max on that one would be 1,280. So that would be a second solution if we wanted to go through that. Okay, so where did that come from? Well, essentially what I did, if you go back to my picture here, remember I said let x and y both be 0, and that gave me a solution? Well, I just did this one at the end. That is a second solution. Now, I'm not going to work all the way around. Matter of fact, I'm not really sure why they're showing you this, but it's in the book, so I'm making sure you know it because it's probably going to show up in the homework. But eventually what I'm going to do is, let me go back, we will start out our problems where we're going to take them and we're going to put them in matrix form. Okay? And then once they're in matrix form, I'm going to show you a method that's going to go through and solve all of this. It's similar to Gaussian, but it's not Gaussian. It's got different rules. And then when you do that, then you're going to actually know what the maximum is. And that's what it's all about. We're trying to find the maximum profit, and I'm going to show you a method to do all of that. Okay, I think the first part of that lesson was kind of simple, and the last part, I probably confused you a little bit. But again, I'm not sure why it's in there, because I think it is confusing. And yeah, it is what it is. Anyway, that's section 401. See you next time.